All right, this question 7. Anya starts drawing a ray diagram for a convex lens. So you've got a diagram of the object, you've got two foci, you've got a lens in between the two foci, and you've got the principal axis. The magnification of the lens is 0.5 and the object height is 1.5 centimeters. Complete the ray diagram to show the size and position of the image. Calculate the size of the image and use your diagram to explain refraction by a convex lens. Okay, so here's the diagram from the question. So you've got the object on the left-hand side, you've got two foci, and you've got the lens in between. So first of all, you need to draw a line parallel to the principal axis. So you draw from the top of the object, you draw a parallel line, and it has to hit the center of the lens. Once it hits there, it has to pass through the focus on the right-hand side. So from there, it has to pass through the focus. I'm just drawing it longer, so then you know where it will intersect. The second line, from the top of the object, it has to go through the focus on the left-hand side. So it has to pass through the center of the lens. So the center of the lens, straight line. So the first line has to be parallel to the principal axis. Once it hits the lens, it has to pass through the focus. So you draw a straight line there. The second line, from the top of the object, and it has to pass through the middle of the lens, but there's no refraction, so it's just a straight line. Ideally, you only need two lines for this, but for the third one, because the first focus on the left is drawn, you need to draw the third line. So from the top of the object, it passes through this focus and it hits the center of the lens. Center of the lens is here. And then from there, it has to be parallel to the principal axis. So from there, it has to be parallel and it hits there. And then from there, you can, where that intersect, that is where the end of the image is. So you need to draw a line from here to the principal axis. All right, so we've drawn the ray diagram to show the size and position of the image. Now we've got to calculate the size of the image and use your diagram to explain refraction by a convex lens. You can see that this is a 6-mark question. Okay, so what is the explanation for the refraction of a convex lens? All right, so the refraction occurs at the boundary between two different mediums or two different media. So the refraction occurs between the boundary of two different media. The speed in air is faster than the speed of light in glass. So the speed of light in air is faster than the speed of light in glass. What happens when light goes through glass? Because glass is more dense, does it bend towards the normal or away from the normal? Make sure you talk about how the light bends as it goes through a different media. And what about the converging of light? So can you see that the light converges after the focus? So here's when it converges. So the light rays converge to this point after the focus. So the light parallel to the principal axis, it meets at the focal point. And what about the image? What about the image itself? So the image is real, it is inverted, and it is after F. All right, so now comes the calculation. You've got the magnification of the lens is 0.5 and the object height is 1.5. What is the size of the image? So what's the equation? So if we know that the magnification is equal to the image height divided by the object height. I mean, that makes sense, doesn't it? If the image is twice as big as the object, then the magnification is twice as big. Because let's just say the object is 1 centimeter and you're magnifying that image and it gets 2 centimeters. So that magnification would be 2 times. So you know the magnification is 0.5. So 0.5 is equal to the image height. So I'm going to write image as I divided by 1.5. So what number I, when you divide by 1.5, you get half. So it's going to be half of 1.5. So 0.5 is equal to 0.75 divided by 1.5. So the image height is equal to 0.75 centimeters.